Hey everyone, and welcome to the Forge College Engineering Department. We're exploring something absolutely crucial today. If you've been writing smart contracts and feeling like your code is getting, just a little tangled or hard to manage, you are exactly in the right place. Today, we're going to upgrade our mindset. We're moving from just hacking together a messy, sprawling contract to designing a pristine, professional blueprint, kind of like drafting clean ink on fresh paper. So let's look at the core principles of contract modularity.
I want you to really think about this question for a second. Is your smart contract doing too much? Writing a monolithic smart contract, where literally every single function, state variable, and logic check is just stuffed into one massive file, is exactly like living in a hoarder's room. Everything is piled up in one place, it's incredibly heavy, and it's basically impossible to find what you need. Plus, if you trip over just one box, the whole pile comes crashing down. In Web3, a heavy contract like that is super expensive to deploy, a total nightmare to audit, and incredibly prone to breaking. We really need to clean house.
Okay, let's dive right into our schematic for today's explainer. We'll start with welcome to the blueprint, then move into separation of concerns, nouns and verbs, the decomposition workflow, and we'll wrap it all up with our key takeaways.
Section 1. Welcome to the blueprint.
Building right on top of our previous lessons in the Solidity from Zero track, you've already successfully built a modular contract skeleton. But now we're transitioning from just assembling pieces mechanically to consciously choosing exactly which pieces to build. And why does this matter? Well, making the right strategic choices about safety, reuse, and maintenance right now is what prevents developers from literally crying over upgradability headaches later on. When a contract is deployed immutably to the blockchain, you want to be absolutely certain your architecture can handle the future.
Section 2. Separation of concerns.
So this is the core architectural philosophy that drives pretty much everything in smart contract modularity. Single responsibility. Think about it like a well-run business. A smart contract shouldn't try to be the accountant, the front door bouncer, and the math tutor all at the same time. If your contract is calculating complex arithmetic, managing user access roles, and holding funds, it's just doing way too much. We need to separate those concerns into dedicated modules to improve both reuse and safety.
To actually connect those separated modules, we use something called cohesive interfaces. An interface acts like a thin, incredibly strict boundary. It defines the public-facing API, basically what other contracts are allowed to call, while keeping all those messy, complex internal implementation details completely hidden away. By relying on cohesive interfaces, you decouple the callers from the specific implementations. It's kind of like being able to swap out the engine of a car without having to change the steering wheel.
Section 3. Nouns, verbs, and primitives.
Now, what's really interesting about this is how we can take abstract Web3 concepts and make them incredibly intuitive just by mapping them directly to elementary school grammar. Think of your modules as parts of speech. Libraries? Those are your stateless verbs. They just do pure computation, no strings attached. Abstract contracts are your protected nouns. They hold the valuable shared state, the actual data, along with internal verbs. And interfaces are your public verbs. They define the external actions that anyone can trigger.
Let's look at stateless libraries first, using a classic MathUtils example. Libraries are your ultimate helpers. Because they use internal and pure functions, they require absolutely zero expensive storage. For instance, a SafeMul function in a library can use a require statement to enforce correctness and prevent overflow without ever clogging up the blockchain state. Plus, depending on exactly how you use them, they're either inlined directly into your compiled bytecode or deployed once and reused. This massively reduces code duplication across all your projects.
Now let's move to how this builds up with abstract contracts, like a FeeAccounting module. If libraries are stateless, abstract contracts are where the storage actually lives in your blueprint. They centralize things like bookkeeping, emitting events like fee charged, and holding your shared state variables. They keep your protected internal behavior perfectly organized. But, and this is a big but, remember that an abstract contract is just a foundational piece. It is never deployed on its own. It literally just waits to be inherited.
Finally, we have the concrete contract, something like our payment processor. This is the final assembly line. The concrete contract orchestrates everything. It implements that strict interface boundary we talked about earlier. It inherits the shared state from the abstract contract, and it calls the library helpers to do all the heavy math. By pulling all these distinct modular pieces together, the concrete contract acts as one independent, swappable, easily maintained deployable unit.
Section 4. The decomposition workflow.
So understanding all these pieces is great, right? But how do we actually apply this to a real messy codebase? Well,
Here is a highly repeatable 5-step workflow for cleaning up your contracts. Step 1. Identify distinct responsibilities. Group your functions together. Is this accounting, access control, math? Step 2. Classify by state dependence. Ask yourself, does it need storage? If no, it's a library. If yes, it's a contract. Step 3. Decide the minimal API surface to reduce coupling. Seriously, only expose what callers absolutely need to see. Step 4. Evaluate your gas and deployment trade-offs. And Step 5, which is crucial. Maintain your invariance and write focus tests for each newly separated module. This isolates your risk and enables safe upgrading down the line.
So the crucial point here is understanding those real-world trade-offs when you evaluate gas and deployment in Step 4. Pure internal libraries cost no extra runtime calls because they just get inlined right into the contract. But if they are huge, they're going to add deployment overhead. On the flip side, breaking logic into entirely separate deployed contracts introduces runtime call costs because, well, the contracts have to talk to each other over the network. However, doing that allows for independent upgrades and smaller deployable units. You always have to weigh those gas costs against your need for upgradability.
Section 5. Key takeaways. We've moved all the way from hoarder room monolithic code bases to beautifully clean modular blueprints today. So here is your ultimate modularity cheat sheet to burn into your mental model for your next build. Ask yourself, no storage needed? Easy, use a library. Shared storage required across different implementations? Use an abstract contract. Need an independent, swappable service? Build a concrete contract behind an interface. And above all else, always, always design minimal interfaces to reduce the coupling between your system's components.
Coming up in our next lesson in this track, we are going to take these exact rules and apply them to well-known production-grade reusable patterns. We'll look at exactly how the pros do it. In fact, I highly encourage you to bring an example contract from your own code base or maybe a small open-source project so we can map these patterns to concrete code together.
I want to leave you with this final provocative thought to test your own system's resilience. If a contract in your protocol fails, is it just a single broken gear that you can easily swap out, or does the entire factory burn down? Modularity is exactly what separates the gears from the factory. Thank you so much for joining this explainer. I really hope this sparks some architectural inspiration for your next project. Be sure to visit forge.college to explore this subject deeper and discover even more Web3 engineering topics. Keep building, and I'll see you in the next one.